Welcome to the start of a new restoration project. This time up, another Admiral TV. No, just kidding, actually. It's a Westinghouse H-196. Yeah, I think I'm going to take a break from more common Admiral and Motorola TVs and do some of my more interesting sets. Not that the Admirals and Motorola's aren't interesting, it's just that I've done a bunch of them already, and this will be a little change of pace, a little bit different circuit design. I got this along with my Sonora 302, I think 2 or 3 years ago. A buddy of mine just showed up one day with them in the back of his truck, and well, I bought them, and here it is. Obviously the chassis is out of the cabinet. I'll show you the cabinet in a moment. It's a bit rough. And right away I could see it was missing some tubes, and I spent quite a bit of time tracking down some knobs for it. But I think electrically all the key components are here and in good condition, including the speaker, which I removed from the cabinet for safekeeping. Points up in the cabinet, so it got rather dirty. It plugs in via this cord, which may need replacing. I don't know. Anyways. I do have the original service info from Riders, Volume 3, so it's one of the earlier TVs out there, being that it's in an early Riders volume, and I think it's probably Westinghouse's first 10-inch tabletop model. There is a little representation of what the complete set looks like. Let's just jump right in and see if we can find the schematic. Now, one thing that's a little interesting about this, and I didn't realize for quite some time after I acquired it, is that there are more controls. So you see these controls up front. We got 4 controls in a row for volume, and then a vertical and horizontal hold, and then a channel selector. But below that is a panel that pops off, revealing all of these controls. You can see them all down up here. So quite a few adjustments you can make on this from the front. It's actually stamped on the chassis, and just by looking at these designators, I can tell this is going to be a little bit different from what I've done before. For example, it appears to have an H-Lin A, H-Lin B, which I assume is horizontal linearity A and B. I've never worked on a set that had potentiometers for horizontal linearity. If they have linearity at all, some sets don't, it would typically be an adjustable coil and only one control. Let's see, what else do we got? Vertical and horizontal centering, which is a nice touch. Most sets don't have that. That will apply, like they rely on magnets like that Admiral Portable I was working on recently, or some kind of contraption here like a focus coil and a gimbal, which this kind of appears to have too. But these will, I imagine, apply some DC bias to the deflection yoke to offset the picture up, down, left, or right. And then we got focus, and vertical linearity, height, and there's the last guy, which probably sensitivity, probably sets an AGC. That has a lock on it. So I imagine it's a rather important control, and one you don't adjust too often, so you got to back off this nut, and then you can control the screwdriver and lock the nut back down. And then here are the more common controls up here. So yeah, we've got some tubes missing, which doesn't necessarily mean there's a problem. It's going to be the damper tube and horizontal output. Oh, sorry, the high voltage rectifier and a horizontal output tube. And there's a flyback down there, rather mounted a bit oddly on its side. Now, just glancing at this looks very familiar to me. Very similar looking to the early RCA and Admiral designs. In fact, I wouldn't be surprised if this was the same type of flyback, just mounted on its side instead of vertically, because they all use the same big old honkin' power resistor here in conjunction with the damper tube to control linearity and width. Well, anyways, let's get back to the service info. This thing is heavy, very, very heavy, very solidly made, huge power transformer. And I think it's kind of amusing that they put little rubber chassis mounts like you see on Philco radios, because this thing is so heavy. These have really bottomed out. Just a little bit of flexibility left in them. But, I mean, they put them there to dampen the vibrations, I imagine, but given that it's so massive, it was really much of an issue. Boy, there's a lot of service info here. I hope this is not a tale of things to come. There's a lot here, a lot here. I'm guessing the schematic may be at the very end of all this. Yeah, here we go. Here we go. It says V2130, so there may be more than one version. I'll have to look into that. Oh, in fact, yeah, here we go. Chassis assembly V2130. Serial number 000009740. I guess they were very optimistic about their production numbers. So I'm going to hazard a guess that this is the 9,740th one they made. But you never know when they actually started numbering these. They may very well have started at 9,000 or 1,000 or anywhere in between. Usually they wouldn't start at 0. I doubt there's like a serial number 1 floating around out there. Alright, so what have we got? Well, let's start at the beginning. Power. Some bypass caps. I need to put some safety caps in there. Power transformer. This is a little bit different. A 5Z4 for a low voltage rectifier and a 5U4 for, well, they call them low voltage rectifiers, but one's going to be like a B plus and one you can think of as a B plus plus. So, and actually it looks like the 5Z4 has the higher voltage on it, but I bet the 5U4 is pumping out more current, but who knows. So this one's about 300 volts after the filtering, and this one 260 volts. Other sets I'd use just maybe like two 5U4s in parallel, like the RCA design, and just use some huge power resistors to with taps on them to generate other voltages it might need. Whereas Admiral and some of their designs and Westinghouse chose to go with two completely separate rectifiers. More efficient, you don't have to have those huge bleeder resistors wasting so much power, but on the other hand it's more complicated, more expensive. You need more windings on your power transformer, you need an extra tube, you need more filtering components, so just a design trade-off. Alright, so let's jump to the other end. So, tuner, antenna in. A little bit different than a tuner as well. 6BH6 RF amplifier. Usually I see some like a 6AG5, and then they use a 6AG5 for the converter. And instead of a 6J6 for the oscillator, they use the 6C4. RCA uses the 6J6 for all three. And some sets use a 6J6, which is a dual triode, half for the oscillator, half for the mixer, so you get this down to just two tubes. Whereas this has quite a few. I think it has 30 tubes in it, which would be the same as the RCA design. Alright, so after the tuner, we get into the IF. I'm curious, they call one an input IF, and then first, second, third stages. I would have just called this a 4-stage IF. But okay, maybe there's no gain on this tube. Maybe it's just a buffer tube. And all 6 BH6s. And does have split carrier sound. So right off the bat, split off the sound, and it's separate IF strip rather than picking it off after the video detector. So jumping up to sound, 6BJ6. Don't think I've ever encountered a 6BJ6 in a TV. Another 6BH6, 6T8, first audio ratio detector, and then 6AQ5 output. Nothing unusual about that. Jumping back to the video, 6AL5D detector and AGC, and then a 12AT7 video amp. A little bit odd. 6AT6 AGC amp. 12AX7 noise clipper, and 6AQ5 video out, and yes indeed, DC restoration. quality higher end sets will have that. And jump back over here. So it uses all three of the dual triode tubes: 12AT7, 12AU7, and 12AX7. All three of which have gotten a bit pricey because of the audio files, especially the AX7. So let's hope that those tubes are good. In fact, they're even able to squeeze enough power out of a 12AU7 to directly drive the vertical output. And for the horizontal, 6AL5 horizontal sync discriminator. Nice, it's probably pretty stable. And 6AC7 variable reactance tube. That's another bit of a different design. The Admiral I've been working on use I think they call it a Synchro Glide, which is a really really popular design. Very stable design. This is a little bit more complicated than that. So 6AQ5 horizontal oscillator, kind of an odd application. Usually you'd use a couple 6SN7s in this design rather than a 6AL5, 6AC7, 6AQ5, 12AU7, and then finally 6BG6 horizontal output tube. So basically, I believe the way this works is this is your variable element that can affect the frequency of the oscillator, and this will compare the incoming signal to the local oscillator, develop a different signal, and this will vary its reactance, thus altering the oscillator frequency so they lock in on each other. And then finally 5V4 damping tube. And there's the flyback and rectifier. I'd mentioned there's centering controls, so here's one for the horizontal. And you can see that's connected right to the yoke, and then up to the vertical as well, which is typical design. It's tapped. You got some large value electrolytics here to filter out any noise, because you want a very stable DC bias on those yokes. If there was any noise or ripple in there, that's going to be very apparent in the picture. So you got 1000 microfarad and a 500 microfarad, bypassing that. And there is the focus coil, electromagnet to focus the electrons. So I did do a video when I first acquired this set and did a quick inspection. I can't remember if I tested the CRT or not. Might as well do that now, and then we take a peek underneath the chassis as well. Kind of getting my bearings on this design here. So yeah, we know this is a high voltage section. There's power transformers, the two rectifiers, and there will be the tuner and the video and audio IFs. Odd place for the AC interlock, pointing straight up. And electrolytic. This one has a cardboard cover. I'm not sure what that would be. I would think that they are both referenced to ground. Ah, that could be this guy. Those large microfarad, which will be also low voltage caps because they are not referenced to ground. Another one there also with cardboard cover. Well, that one definitely is not for... Huh, maybe this isn't... I was assuming that this tap here, the center tap, was ground, but maybe it's not, because I have a ground symbol over here, and this doesn't go to it. Let's go into these caps, and over and over. Focus coil, and down and around. And yeah, I don't think that must be a negative voltage, the reference to ground, so that'll be something else to watch out for. Too bad they don't give you the voltage on that. I'm guessing it's slightly negative, not going to be hundreds of volts negative, but a few volts negative. Oh, let's see, there's the antenna input terminals. Alright, so I'll test the CRT in a moment, and now I'm going to flip this guy on its side and take a peek underneath. Oh, and speaking of CRTs. Hoping to have a little fun with this set too. Once I get it working, I'm going to pop this little CRT into it. It's a 7-inch. Has the same type of base, and the voltages should be compatible enough that produces an image. What this is a 7ABP14A. I think that's what it is. Picked this up off of eBay recently. Military radar CRT. I'm curious to see how it works out. A similar deflection angle. Actually, this could be used in an RCA 621 TS2, almost. The 621 CRT uses a 17DP4, I think, which has a electrostatic focus that runs on a few thousand volts, whereas this is a low voltage electrostatic focus. But other than that, same deflection angle, same base, and I think similar dimensions. And P14 is a little bit unusual. We'll see how that turns out. It's not your typical colors that you see coming out of a CRT face. Alright, so back under here. Yeah, look at all that. That's going to be a lot of work. So there's a huge transformer. Some serious iron there. And oh, what a mess. Looks like no work has ever been done, or maybe minimal amount of work. That might be a replacement. Well, I see a few others that look like that, and they're underneath other components, so maybe not. And then we got this one, which I think just broke loose. I don't think that's necessarily evidence of somebody working on it. So we got bumblebee caps. Those got to go. We got these guys, which are a little bit different looking, but I believe these are capacitors as well. I don't think I've seen these before. Kind of an odd coating to them. Almost feels like it's a ceramic tube. There's ceramic or plastic tube with a capacitor inside, sealed up at the end. It's not a waxy coating like you'd see on like a cap like this, and it's not hard plastic like a bumblebee or black beauty. Regardless, no doubt leaky. And dead spider there. Get that out of the way. Fuse, nice sign. That's fuse on flyback. So, assuming that somebody didn't tamper with it, it should have protected things from overloading. Yeah, it's still a 1/4 amp fuse. Cool. And yeah, we've got some oddness in here. So, for example, we've got this long shaft running all the way through here to a control way back here. And what is that? That's contrast. Why would the contrast control have to be located at the back end of the chassis instead of having it up here and just run some wires back? I do not know. It probably controls the bias on the video amp. Sensitivity control, not sure what contrast. There's brightness. I'll figure it out. It might control the gain. Might be part of the AGC circuit. I don't know. Oh, yeah, there it is. There it is. I actually have a video test jack on this thing. It's a nice touch. So actually, apparently there is a be like a volume control for the video, where it's referenced to ground, and they vary the level and then feed it into the video amp. I've never seen that before. They usually vary the gain on the video amp, like have that resistor in the cathode. Huh. Definitely want to look through these design notes, because I think they go through quite a bit of theory of how these circuits work and all that paperwork. Alright, back under here. There's the caps, bypass caps right off of the AC line, and these tend to go boom when you try plugging these sets in. Might be mica, actually. I've seen that style before on these AC line caps. I think it says mica mold on there. It doesn't necessarily mean they're mica, just it's a mica mold company. Alright, so what to do first? So I'll test the picture tube, and I also want to try powering this up with the two rectifier tubes out of their sockets, just to make sure the power transformer is okay. I'm using my recently restored RCA WT509A to test the picture tube, and thanks to Mike on the Antique Radio Forum, I now actually have the setup chart to go along with the brief instructions on the inside cover. So, I think we've got everything set up here, black and white. Heater is on D, using socket adapter 3, both G1 and G2 are low. So check for leakage. That is good. G1 leakage, good. Now I believe we do the cutoff adjust. Hey, great. Plenty of cutoff control. Set it for 2 ticks. And we check emissions. Ooh, that's not so great. But, hey, look at that, they're steadily climbing. I'll sit for a while, but hey, that'll produce an image. I'm not worried. I'm not worried about that. And even if it didn't, I've got spares. A little more concerned is that it's kind of loose in here. So I've got a metal band around the front with some rubber on it. And some cushioning inside the metal band all the way around. So this probably is hardened and shrunk a bit. These are tight. I can loosen these up and push this tighter against the CRT. You definitely don't want it to be that loose. This focus electromagnet's pretty loose too. Tighten that down. Should not be flopping around like that. And I got under the green. Cool, so maybe not the greatest life, or not the greatest emissions, but certainly it will be usable. And I imagine the longer it sits here, the more it will climb. Alright, so next I want to try powering this up. But before I do that, I think I'll clean this off a little bit. Got some all kinds of dirt and on this. No corrosion though. Imagine this is cadmium plated, and it's held up pretty well. Oh, maybe some of these rivet heads have a little bit of corrosion, but the main body of the chassis looks fine. Definitely want to get the dirt and debris out of the AC interlock. Okay, got things cleaned up a little bit in this area, and I noticed that around some of these controls, coils in particular, there's like a white paint that was, or off-white paint that was painted around here. Well, in the cleaning process, I chipped some of it off. See how nice and pretty the cadmium plating is under it. Some more intact over here. I'm not sure what that was there for. I don't know if that's holding these in place or preventing anything from getting down and around the openings for them. I don't know. I don't know if I should replace it, just leave it as is. For now, I'll just leave it as is. So, cleaned out the AC interlock, got a cheater cord plugged in, and I did clip out the caps down below that were on the AC line. Just there to filter out some RF noise from the AC line, and you can power up the stuff fine without them. So rectifier tubes out. Oh, and I noticed on the schematic I studied a little bit more closely that there actually is only one secondary winding. But there are 2 filament windings for the rectifier tubes. So it'd be like having 4 diodes. So there's just sharing a secondary, so actually very similar voltage coming out of these tubes, just a little bit different filtering. So one has a filter choke, a pi filter, and the other one is a little bit more simplistic filtering with just a cap going to ground essentially. Alright, so without further ado, plug in my PR57. I have it turned off right now. So I'm just going to be looking for tubes glowing. That's it. If tubes glow, it's a good sign. Then we'll move on to testing the secondary voltages. So here we go. Oh, let's turn PR57 on. Now here we go. Alright. Sag down a bit until it's drawing current, not excessive. About 0.6, 0.7 amps. Tubes are basically all lit up. Some of them are a little dirty, so it's hard to tell. All lit up, including the CRT, so excellent. Including the damper tube, good, because the damper tube has a separate filament winding dedicated just for it. Because a 5V4 they're using for a damper has the heaters connected to the cathode, so you cannot have anything else connected to that. Alright, so moving on to secondaries. So all I gotta do is basically check out pins 4 and 6, and it should be like around 700 or 800 volts. They don't specify the unloaded AC voltage on the secondary, but that's what experience tells me. So 1, 2, 3, 4, 5, and 6. 674 volts. That looks good to me. Again, unloaded, but hey, I have yet to find a bad power transformer TV. Knock on wood, I'm sure I will someday. But my luck has held out pretty well, and I think it has again. Alright, so now what? Well, I could populate the missing tubes and hook up the speaker and just, hey, let's just fire it up. But I already know that there's going to be problems in it, that some of these caps are going to be bad, and I just as soon start methodically going through and replacing components, starting with the power supply. And we can check out the flyback too, see if we can get that cover off. Also thought you might like a look at this side of the chassis. So here's the tuner, big heavy lead shield around this guy for stability and reduced microphonics. I believe that's the local oscillator tube. And here are the IFs. Please believe this is sound, and this big one here would be the ratio detector. This is probably 6AQ5. Yep, there is your sound output. And here is the connector going to the speaker. So placement on all that stuff, it makes sense. And there are more electrolytics hiding down in here. I bet the squat guy, yep, 1000 microfarad, 500 microfarad. So this is that high capacitance filter for the centering controls. I almost forgot to show you guys the cabinet. Here it is, sitting on top of my Motorola VK106. So you can see it's definitely seen better days. Finish is very dry, flaking off, alligatoring. Got some chunks of veneer missing. So definitely a refinish candidate. Fortunately, that will mean losing decals. Which, now that I look, I can't even tell if there were any decals up here or not. You see the channel plate's also very worn. Well, here's that board I mentioned that comes off. Let's pop that out. There we go. It's held on by some clips on either end. So that's how you get at those controls in the lower part of the chassis. And I just realized the labels for these controls aren't above them. They're on this piece of wood up here. They're in okay condition, but the finish around them is so deteriorated, I don't really know if I can save them. I have, however, taken reference photos and may get replicas made. Here's the safety glass, reverse painted, nice Westinghouse logo. It's got a couple flaws here and there, but otherwise, overall it's a decent condition. That speaker, I think mounts up here, and this panel comes out, as memory serves, missing the back. So yeah, a lot of work all around. Veneer that's left is loose in places, it needs to be glued down. I need to put some veneer patches in, strip it down, do something about the decals, refinish the whole thing. Maybe I'll get to it this summer, maybe not, but at least I get the electronics working. And here are the knobs that I've managed to scavenge up. It'd be nice to get an all metal knob set. I've only got one of them, but there are early versions of these knobs that are solid metal. I think brass plated steel. But these are definitely Westinghouse knobs. They switched from metal to plastic at some point. I don't know when. Some of these knobs are easier to find than others. I've got a number of the channel selectors. I had some more difficult time finding the inner knobs because they are not all the same. Some are smaller inner diameters than others. But I do believe I now have a complete set. The fine-tuning one is obviously a little different than the others. So, something like that.